Hello guys, welcome back to the channel Mathemagix JEE. Welcome guys to this PYQ discussion series of JEE Main 2025 questions where we are going to solve chapter wise problems from JEE Main 2025 Mathematics. Okay, I would recommend you to have a thorough revision of the chapter complex numbers before attempting this 13 problems. Okay, so in this session we have 13 questions in total to discuss from the chapter complex numbers. So let's begin this session. So the first problem here we have, this is, let z be a complex number, okay, such that mod of z equal to 1. Okay, so z lies at a distance unity from the origin of the complex plane, right? If 2 plus k square z divided by k plus z bar equal to kz, where k belongs to r, then the maximum distance of k plus iota k square from the circle mod of z minus 1 plus 2 iota equal to 1 is what? Okay, so our first objective in this problem will be to find this value of k, right? So somehow we have to find the value of k so that we can find this complex number here, k plus iota k square, and then we can find the maximum distance from this complex number from the circle, right? So we can say, if we write this equation here, 2 plus k square z divided by k plus z bar equal to kz, right? So we can take this in the right hand side, right? Because here we can see easily k times kz will give us k square z, which will cancel this k square z in the LHS. So then this term will be cancelled, so we get k square z cancel, and z bar times kz equal to 2, right? And z bar times z we know already is equal to mod of z square, right? We know that z bar equal to mod of z square. So we can write this as 2 plus k square z equal to k square z plus k mod z square, right? This gets cancelled, and this thing we already know. This is given in the statement that it is equal to 1, right? This mod z equal to 1, that means we get k equal to 2. So from here we can find this complex number easily, k plus iota k square. So let's call this w. Okay, w becomes this 2 plus iota times 4. So if we consider this circle here, right, this circle geometrically, it is centered at the point 1 comma 2, so like here, and then it is of radius 1, right? So 1 comma 2 means this circle touches this y axis, so like this is the point 1 comma 2, and this is the point 2 comma 4, right? 2 comma 4, so somewhere here. So we can find the maximum distance of this point 2 comma 4 from this circle, right? This will be nothing but the radius of this circle plus the distance between these 2 points 1 comma 2 and 2 comma 4. So let's call this d. So maximum distance will be d plus r, right? So d plus r will be, this is how much? This is 1 square plus 2 square under root plus this r is 1, right? So we have maximum distance as root 5 plus 1. That means we have this option 1 as our correct option. So let's proceed with the next problem. Okay, so this is the next problem here. Let's say here we are given, let z belongs to the set of complex number be such that z square plus 3 iota divided by z minus 2 plus iota equal to 2 plus 3 iota, right? So we write this equation first here, z square plus 3 iota equal to 2 plus 3 iota times z minus 2 plus iota, right? So we are getting z square plus 3 iota equal to, this will be how much? This will be 2 plus 3 iota times z minus this 2 minus iota times 2 plus 3 iota. So from here we are getting z square minus 2 plus 3 iota into z plus this 2 minus iota times 2 plus 3 iota plus 3 iota equal to 0, right? So now if we simplify this thing here, it will be equal to z square minus 2 plus 3 iota z plus this will be 4 plus 3, right? So 7, then it will be plus 6, then minus 2 means plus 4 iota. plus 3 iota, right, equal to 0. That means z square minus 2 plus 3 iota times z plus this will be 7 into 1 plus iota equal to 0. So now we have to find the sum of all possible values of z square, right? So we can say from this quadratic equation that this quadratic equation will have two roots, right? So let's say z1 and z2, because we are dealing with complex numbers, so there exist exactly two roots in the complex plane. So we can say sum of all possible values of z square will be nothing but z1 square plus z2 square, right? So this we can easily calculate by the theory of equations. We know this can be written as z1 plus z2 whole square minus 2 z1 z2, right? So z1 plus z2 is our 2 plus 3 iota, its whole square, minus then 2 times this z1 z2 will become 7 into 1 plus iota, right? So we have here this will be minus 5 plus 12 iota, right? Minus this will be 14 minus 14 iota. That means it becomes minus 19 minus 2 iota. So in this case, our correct option will be option number 2, right? So 2 is the correct option for this question. Let's proceed with the next problem. Okay. So here we are given, let A equal to this set. Okay, so this set we can see z belongs to the set of complex numbers such that mod of z minus this we can write as bracket 2 plus iota, right? So we know this is an equation of a circle which is centered at 2 comma 1. This modulus is equal to 3, that means the radius of the circle is equal to 3, right? And for B is the set real part of z minus iota z equal to 2. That means here real part of z minus iota z equal to 2. That means real part of z minus real part of iota z equal to 2, which means real part of z is x minus real part of iota z will be what? It will be minus y, right? Because z equal to x plus iota y, so iota z becomes iota x minus y, right? So then it is equal to 2. That means this A set here it is the circle centered at 2 comma 1 with radius 3, and this B set here it is equal to the straight line x plus y equal to 2, right? And S is the intersection of these two sets, right? So what does this mean? The intersection means we have to find the common z that belongs to both of the set. That means we have to simply find the intersection points of these two curves, this circle and this line. So let's say if this is the circle, then this is the line, then let us write the equation of the circle first. It will be x minus 2 whole square plus y minus 1 whole square equal to 3 square, that is 9, right? So we can solve these two equations here to find the corresponding values of x and y, so that we can find the corresponding z, right? So let us try to find this. We can substitute the value of y from here, y equal to 2 minus x, that means x minus 2 whole square. If we consider these two equations here, we get x minus 2 whole square plus y will be 2 minus x, then minus 1 will get 1 minus x, then it will be whole square, right, equal to 9. So from here we can say x square minus 4x plus 4 plus x square minus 2x plus 1 equal to 9. So from here we can say 2x square minus 6x plus 5 minus 9, that is minus 4, okay, equal to 0. That means x square minus 3x minus 2 equal to 0. Now see, here is an important trick, okay? So in this case we can see the roots are going to be, the roots of this quadratic equation are going to be something which is not typical. The roots will contain irrational terms. That means we cannot perform multiplication or addition with them. That will be quite hectic. So we avoid that part. Okay. So now how to find this term here, summation of mod z square? This we can find. This we can write as summation. This mod z square will be nothing but x square plus y square, right? So we can write this as summation x square plus y square, right? So now if we evaluate this summation x square plus y square, So summation x square plus y square will be what? It will be x1 square plus x2 square plus this y we can write as 2 minus x, right, from here. So we can write this as 2 minus x1 whole square plus this will be 2 minus x1 whole square, right? Sorry, x2 whole square, right? So now we can find x1 square plus x2 square easily from this equation. X1 square plus x2 square will be summation x1, that means summation xi whole square minus this will be 2 times x1 x2, right? So it will be 3 square, that is 9, minus 2 times this will be minus 2, that means 4, right? So this will be 13. So from here x1 square plus x2 square is equal to 13 plus, now this thing we have to calculate. Okay, so for this expression we can find easily, this will be 4 plus x1 square minus 2x1, sorry, this will be 4 plus x2 square minus 4x2, right? So from here again x1 square plus x2 square is equal to 13, then plus 8, right? Then minus 4 times x1 plus x2. So that means 4 times x1 plus x2 we can write as 4 times 3. That means this becomes 1 plus 8, that is 9, plus 13, that is 22. Okay, so this is how we can easily calculate the required expression value without finding the actual values of x and y. Okay, so the correct answer for this problem will be 22. Let's jump to the next problem. Okay, so in this problem we have, if alpha is the root of the equation x square plus x plus 1 equal to 0 and summation k equal to 1 to n alpha to the power k plus 1 by alpha to the power k whole square is equal to 20, then n is equal to what? Okay, so at first we have to find the roots of this equation, right? So we know this equation, the roots are pretty standard. Okay, so the roots of this equation are omega and omega square, right? Where omega is the complex cube root of unity. Omega is minus 1 by 2 minus iota root 3 by 2. Okay, so then we have summation k equal to 1 to n alpha to the power k plus 1 by alpha to the power k equal to then square equal to, this summation is equal to 20, right? So we can consider alpha to be either omega or omega square. It doesn't matter because this omega and omega square are symmetry about each other. So we can assume that, let's say, alpha equal to omega. Okay, so this summation is summation k equal to 1 to n, then omega to the power k plus 1 by alpha to the power k, right? So 1 by alpha we can write as 1 by omega, which is again equal to omega square. Okay, because we know the property that omega cube equal to 1. That means omega equal to 1 by omega square. Okay, so we can write this as omega square whole to the power k, that means omega to the power 2k, this whole square. Okay, so how to find this summation? Let us first analyze the behavior of the term inside this summation. Okay, so let us put k equal to 1. So for k equal to 1 we can say this will be omega plus omega square, right? This is, we know, equal to minus 1, right? Because we know the property omega square plus omega plus 1 equal to 0, right? And for k equal to 2 we can find the term here. This will be omega to the power 4 plus omega square. Okay, so omega to the power 4 is again omega, we know omega cube is 1, so omega to the power 4 is omega. That means this will become omega plus omega square equal to minus 1 again, right? And for k equal to 3 we can say this will become omega cube plus this will be omega to the power 6. Okay, and omega cube is 1 and omega to the power 6 we can write as omega cube then whole square, so it will also be equal to 1. That means this term will be equal to 2. Now we can see easily that this pattern gets repeated over a cycle of 3. Okay, so for k equal to 4 it will be again minus 1, k equal to 5 it will again be minus 1, and k equal to 6 it will again be 2. That means the pattern of this term here, if we consider this whole square here, this pattern will be equal to minus 1 whole square, that means 1, then 1, then 2 square, that means 4. Okay, then again 1 1 4, then again 1 1 4. Okay, like this will go up to infinity. Okay, so why this periodicity over 3? Because we are dealing with the complex cube root of unity. So we can see here that if we consider the first three terms, the sum will be 4 plus 1 plus 1, that means 6. Okay, and for the next three terms the sum is again 6, right? And for the next three terms the sum is again 6. That means here we covered up to 18. Okay, so we can say here this total sum is 18. So we have to get next two terms for the sum to be equal to 20. So the next two terms will be 1 and 1, right? So we can say if we consider the next two terms as well as this 18 here, the sum will be total. Here the sum will be total 20, right? So how many terms are there? This is n equal to 1 2 3 4 5 6 7 8 9 10 11. Okay, so our n will be equal to 11 in this case. I hope you understood the behavior of this series. Okay, the terms of this series are repeating over a cycle of 3. Let's proceed with the next problem. Okay, the next problem we have here, we are asked to find among the statements which of the statements is correct and which of them is incorrect. Okay, or we are to identify if both are incorrect or both are correct. So let us first verify these statements. Okay, so in the first statement it is saying the set z belongs to c minus minus iota. Okay, so we are removing this minus iota because this is not in domain, right? And then mod of z equal to 1 and z minus iota divided by z plus iota is purely real, contains exactly two elements. Okay, and s2 says that the set z belongs to c minus minus 1, mod of z equal to 1 and z minus 1 divided by z plus 1 is purely imaginary, contains infinitely many elements. Okay, so let us first verify this statement 1. Okay, so statement 1 says this z minus I divided by z plus I. Okay, this is purely real. Now tell me what is the condition for a complex number, let's say w, purely real. Okay, so we know the condition. If w is a complex number which is purely real, w should be equal to w bar. Okay, and if w is purely imaginary, then w plus w bar will be equal to 0. Okay, so these are the conditions we have to use here to verify this given two statements. Okay, so let us do this here also. Z minus iota divided by z plus iota is purely real. That means we can say this is equal to the conjugate of itself. Okay, so if we take the conjugate here, this conjugate we can again distribute over multiplication as well as addition subtraction, right? So this we can write as z bar minus iota bar, which is minus iota. Okay, so this will become plus iota, right? Divided by this will be z bar, then this will be minus iota. Okay, so if we solve this equation, we get z minus iota times z bar minus iota is equal to z plus iota into z bar plus iota. Okay, so from here we can easily simplify this. This will become I square is minus 1, that means minus 1 plus this will be minus then iota times z plus z bar, then it will be plus z bar, which is mod z square. Okay, and then we have again mod z square plus iota times z plus z bar, then here again plus iota square, which is minus 1. Okay, then we have from here z square is cancelled, minus 1 is cancelled, that means 2 times iota times z plus z bar equal to 0. So from here we can easily say that I is not 0, 2 is not 0, that means z plus z bar should be equal to 0. Now what does this indicate? This indicates that z should be purely imaginary, right? The condition that we just discussed, that w plus w bar equal to 0, means that w is a purely imaginary complex number. That means z is purely imaginary. Okay, so how many purely imaginary complex numbers are there within this circle? Okay, so this circle is basically mod of z equal to 1. That means the unit circle. Okay, so in the unit circle we have 2 points which are purely imaginary, iota and minus iota. But see here that minus iota is excluded from the domain, right? So we can say only the solution that exists for this case will be z equal to iota. So this is the only solution. But here in question, here in statement 1, okay, it says that this set contains exactly 2 elements. That is false. Okay, so this is false. Let us check statement 2. So for statement 2, we have this mod of z equal to 1. Okay, exactly the same circle, and z minus 1 divided by z plus 1 is purely imaginary. That means we can say, if we consider this number here, z minus 1 divided by z plus 1, this plus the conjugate of itself, which is this number, okay, their sum has to be equal to 0, right? This is, we are checking statement 2. So from here, z minus 1 divided by z plus 1 plus this will be z bar minus 1 divided by z bar plus 1, right? Because 1 is purely real. So this will be equal to 0. That means we can say this will be z into z bar. So mod z square plus z minus z bar, then minus 1. Okay. Plus this will be mod of z square plus z bar, then minus z, then minus 1. This is the numerator. The numerator has to be equal to 0. Okay, like this. So we have from here, if we cancel these factors, z bar gets cancelled, z gets cancelled. So we get 2 times mod of z square minus 1 equal to 0, right? So how many complex numbers are there which satisfies this equation as well as mod of z equal to 1, right? Yes, there are infinite number of complex numbers, right? So that means there are infinite number of elements in this set. Okay, this set contains infinitely many elements. That means this is true. So our statement 2 is correct and statement 1 is incorrect. That means only S2 is correct, which means option 3 will be our correct option for this problem, right? So let us jump to the next problem here. Okay, if the locus of z belongs to the set of complex number such that the real part of z minus 1 divided by 2z plus iota plus real part of z bar minus 1 divided by 2z bar minus iota is equal to 2, is a circle of radius r and center a comma b, where 15ab divided by r square is equal to, okay, so that means we have to solve this equation first. Okay, find the locus. Now how to find the locus? We can substitute z equal to x plus iota y. Okay, because we are dealing with only simple addition and subtractions here, so we can substitute z in Cartesian form. So we can write here that real part of z minus 1 divided by 2z plus 1, 2z plus iota, sorry, plus real part of this. Now see, here is an interesting observation. We don't need to actually calculate this one. Okay, because if you closely observe, this is the complex number inside this bracket is the conjugate of this complex number. Why? Because if you take the conjugate of z minus 1 divided by 2z plus iota, you will get the exact same complex number as this. Okay, so we can say real part of w bar equal to real part of w, right? We all know this, so we can use this property here. So this will be nothing but real part of this complex number. Okay, so we can multiply it by 2 here, and this will be equal to 2. That means from here, real part of this complex number here, z minus 1 divided by 2z plus iota, will be equal to 1, right? So let us calculate this. It will be x plus x minus 1 plus iota y divided by, this will be 2z will be 2x plus 2 iota y. That means 2x here plus iota times 2y plus 1. Okay, so if we calculate the real part of this, that means it will be, here it will be 4x square plus 2y plus 1 whole square, then it will be x minus 1 plus iota y times 2x minus iota times 2y plus 1, okay, equal to 1. That means from here if we calculate the real part only, it will be this into this, right, minus this into this, okay. So this will be 2x into x minus 1, then it will be plus and minus, so minus and then again minus, so it will be plus overall y into 2y plus 1, okay, equal to this 4x square plus 2y plus 1 whole square. How? Because we took the real part. The real part of this left hand side will be this divided by 4x square plus 2y plus 1 whole square, right? And this real part is equal to 1. So we took this 4x square plus 2y plus 1 whole square in the right hand side. So from here we get this will be 2x square minus 2x plus 2y square plus y equal to 4x square plus 4y square plus this will be 4y plus 1, okay. So if we simplify this, this will become, if we take the x and y in any of these sides, we get 2x square plus 2y square, then it will be plus 3y plus 2x, so plus 2x plus 3y, and then plus 1 equal to 0, okay. So from here we get x square plus y square plus x plus 3 by 2 y plus half equal to 0. So this is the equation of the circle on which z is lying. So we can find easily the radius and center. Center will be minus 1, sorry, minus half, and it will be minus 3 by 4, okay. And for this radius we can say radius will be under root 1 by 4 plus 9 by 16 minus this half. So if we calculate this, this will become 16. So then 4 plus 9 minus 8, this under root, so under root 5 divided by 4. So we calculate this number here, 15 AB, 15 times AB is equal to half into 3 by 4, that is 3 by 8, times 1 by r square is 16 divided by 5, right? So if we calculate this, 5 cancels this 15 with 3, 8 here will cancel this 16 by 2, so 3 3 is a 9 times 2 is power 80, okay. So option 3 will be the correct option in this case. So we can see this question was a bit calculative one, because we had to derive the equation of the circle and as well as find the center and the radius, okay. We have to keep proper patience while solving this type of problems, okay. So let us jump to the next problem here, okay. Here this question is saying let a equal to this set, okay, theta belongs to close 0 to 2 pi such that 1 plus 10 times real part of this complex number is equal to 0. Then summation theta square, where theta belongs to this set a, is equal to what, okay. So let us first find the real part of this complex number, okay. Real part of 2 cos theta plus iota sin theta divided by cos theta minus 3 iota sin theta. So we can see easily, we can multiply by its conjugate here in both numerator and denominator. So we will get real part of 2 cos theta plus iota sin theta times cos theta plus 3 iota sin theta divided by this will be cos square theta plus 9 sin square theta, right? This real part is equal to minus 1 by 10, right? So if we calculate here, real part of this will be nothing but 2 cos theta times cos theta, which is 2 cos square theta, then minus sin theta times 3 sin theta, that means 3 sin square theta, divided by cos square theta plus 9 sin square theta. Now see, cos square theta plus sin square theta we can write as 1, so it will be 1 plus 8 sin square theta. Okay, 1 plus 8 sin square theta, it is equal to minus 1 by 10. Now we can convert the whole expression into a single sine or cosine term. Okay, I am preferring sine because sine is easier to handle than cos. So if we convert this cosine into sine, we get 2 minus 2 sine square theta minus 3 sine square theta. That means 2 minus 5 sine square theta divided by 1 plus 8 sine square theta is equal to minus 1 by 10. Okay, so from here if we calculate, this will be how much? 20 minus this will be 50 sine square theta is equal to minus 1 minus 8 sine square theta. So from here if we calculate, 42 sine square theta is equal to 21, which means sine square theta is equal to half. Okay, so sine square theta is half, that means sine theta can be plus minus 1 by root 2. So what will be the solutions? We can see by the graph that there will be 4 solutions. Okay, this is the line y equal to 1 by root 2, this is the line y equal to minus 1 by root 2, and this is the graph of y equal to sine x. So there are 4 solutions. This solution is pi by 4. Okay, pi by 4. This solution is 3 pi by 4. This solution here it is 5 pi by 4, and this solution will be 7 pi by 4. Okay, so we have the sum of theta square as pi square by 16 plus 3 square pi square by 16 plus 5 square pi square by 16 plus 7 square pi square by 16. Okay, so pi square by 16 we can take as common, and then it will be 1 plus 9 plus this will be 25 plus 49. That means pi square divided by 16 times this will be 35 plus 49. So 35 plus 49 will be 4 and then 8, right? So 84, which means if we cancel by a factor of 4 here, 4 4s are 16 and 421 is 84. So it comes out to be 21 by 4 times pi square, right? So summation theta square, where theta belongs to the set A, will be equal to 21 by 4 times pi square, which means option 1 is our correct answer. I hope you understood the concept of trigonometric equations used in this problem. Okay, so let us jump to the next problem. Okay, let z1, z2 and z3 be 3 complex numbers on the circle mod of z equal to 1 with argument of z1 equal to minus pi by 4, argument of z2 equal to 0, argument of z3 equal to pi by 4. Okay, so we have this 3 complex number. Okay, on the unit circle, let's say this is the unit circle mod z equal to 1, right? And we have this argument of z1 equal to minus pi by 4. That means this complex number z1 will be situated somewhere here, right? And argument of z2 equal to 0 means this will be somewhere here. Argument of z3 will be pi by 4. That means this will be here. Okay, this is our z3, this is z2, this is z1, right? So we can write this thing as this we can write as z1 equal to 1 times e to the power iota minus pi by 4. That means e to the power minus iota pi by 4. z2 is basically 1, right? Because this point is 1 comma 0, and z3 is basically e to the power iota pi by 4. That means we can easily calculate this mod here. This expression will be z1 z2 bar. So z1 z2 bar is basically e to the power minus I pi by 4 plus z2 z3 bar. So this will be e to the power minus iota pi by 4 plus this will be z3 z1 bar. So z3 times z1 bar will be e to the power 2 iota pi by 4 mod whole square. Okay, so from here we can calculate this 2 e to the power minus I pi by 4 plus e to the power 2 iota pi by 4 mod whole square. So we can expand this e to the power minus iota pi by 4 is 1 by root 2 times 1 minus iota, right? Similarly, this e to the power 2 iota pi by 4 will be equal to e to the power iota pi by 2, which is equal to iota, right? So this will be iota. So from here we get this will be 2 times this complex number will be root 2 minus root 2 iota plus iota, this modulus whole square. Okay, so this will be root 2 square, which is 2 plus this square. Okay, this root 2 minus 1 whole square. So root 2 minus 1 whole square will give us uh, this will be 3 minus 2 root 2, right? So from here we can say this will be equal to 5 plus, sorry, 5 minus 2 root 2. Okay, so we can calculate this alpha and beta from here. Alpha will be equal to 5 and beta will be equal to minus 2. That means alpha square plus beta square will be equal to 25 plus this will be 4. That means 29 will be the correct answer for this problem. Okay, so this was an easy question. Just we had to identify the complex number on this unit circle. Okay, the next problem here, it is saying let the curve z into 1 plus iota plus z bar times 1 minus iota is equal to 4. Okay, z belongs to the set of complex number. Divides the region mod of z minus 3 less than equal to 1 into two parts of area alpha and beta. Then mod of alpha minus beta equals 1. Okay, so we are given this locus here, right? Plus z bar 1 minus iota equal to 4, right? So we have to first decode this curve. Okay, so we can observe here similarly that if we consider this to be some complex number w, this becomes our w conjugate. Okay, so this is nothing but w plus w bar, which is equal to, we know, 2 times real part of w, right? So 2 times real part of z into 1 plus iota, this should be equal to 4. That means if we calculate here, we get this will be 2, right? Real part of x plus iota y times 1 plus iota. Okay, this should be equal to 2. That means x then minus y equal to 2. So this is our locus of z, right? It divides the region mod of z minus 3 equal to 1 or less than 1. Okay, so what is this region? Let us sketch this. So we have this closed circular disc, okay, of radius 1 centered at 3 comma 0. So like this. So we can say this point here will be our 2 comma 0 and this point here will be 4 comma 0, right? And this line x minus y equal to 2 will pass through this 2 comma 0, right? This will intersect the circle somewhere here, and this point is vertically above this center. Okay, so if we join this, it becomes a right angle triangle. So we can see divide into two parts of alpha and beta. So alpha will be, let's say, this part. Okay, alpha we can take any of these two regions and the other region will be beta. That means we can take this white region here to be our alpha, right? And this, let's say, yellow region here we can take as beta. So we have this alpha. If we calculate, alpha will be the area of the quarter circle, which is pi into r square. R is 1, so pi divided by 4, right? Minus area of this triangle, right? This point here, it is 4 comma this 1, right? 4 comma 1, sorry, this point will be 3 comma 1, right? So 3 comma 1, and then so the area of this triangle here, if we closely look at it, this triangle here, right? I am shading with this green color here. Okay, the area of this triangle is half into this is 1 and the base length is 1, right? So this is basically pi by 4 minus half. Okay, and for beta we have similarly this region, right? This yellow region. So yellow region, this pi by 4 times 3 plus the area of this triangle, which is half, right? So if we calculate this alpha minus beta magnitude, it will be pi by 4 minus half minus 3 pi by 4 minus half this modulus. Okay, so if we calculate this, this becomes 1 plus pi divided by 2. So in this case, option 1 will be our correct option. So let us jump to the next problem. Okay, so this is the next problem. Here it is saying, let this curve be equal to 1 by 3. The modulus of this complex number is equal to 1 by 3. Okay, be the equation of a circle with center at C. Okay, if the area of the triangle whose vertices are at the points 0, 0, C and alpha, 0 is 11 square units, then alpha square equals what? So we have to first find the equation of this circle. Okay, so that we can find the center of that circle. So we proceed by interpreting this modulus. Okay, so we know mod of w is equal to mod of w bar, right? If w is a complex number, so we can use this property here to write this as z plus iota, right? And then 2z minus iota. This modulus is equal to 1 by 3. So if we square both sides, we get this square will be 1 by 3 whole square, which is equal to 1 by 9, right? So then mod of z plus iota whole square will be x plus 1, x square plus y plus 1 whole square, right? Because this will be x plus y plus 1 times iota. And then divided by this will be modulus of 2z minus I whole square will be 2x whole square plus 2y minus 1 whole square is equal to 1 by 9. Okay, so then we have 9x square plus this will become 9y square plus 18y plus this will be 9, right? And then it will be 4x square plus 4y square minus 4y plus 1. So if we take all the terms in one of the sides, we get 5x square plus this would be 5y square, right? Then it will be plus 22y plus 8 equal to 0, right? So we have x square plus y square plus this 22 by 5 y plus 8 by 5 as equal to 0. So this is the equation of this circle, right? So now the center will be this C is equal to minus 11 by 5 comma this this will be 0 comma minus 11 by 5, right? So this is our C. Now if the area of the triangle whose vertices are the points origin, okay, so let us draw the rough diagram in this case. Okay, this is the origin, let's say, and we have this alpha comma 0. So we can take anything anywhere this alpha point, it doesn't matter whether this side or this side. So let's take this alpha comma 0 here and this point here 0 comma minus 11 by 5 here. Okay, 0 comma minus 11 by 5 as this. So in this case we have the area of the triangle will be half times base into height, right? So half times base length is mod of alpha, right? Because alpha we already taken as a positive quantity in this case, so mod of alpha will be equal to alpha. But if the situation was reversed, let's say alpha was on this side, okay, then we would have taken mod of alpha. So times this will be 11 by 5, right? This is equal to what? 11 square units, like this. Okay, so we have this 11 cancelled from this equation. So mod of alpha square will be alpha square itself. So alpha square will be 100, right? So we have option 1 as our correct option in this case. So let's jump to the next problem. Okay, so we have here this problem. The number of complex numbers z satisfying mod of z equal to 1 and mod of z by z bar plus z bar by z equal to 1. Okay, so we have these two simultaneous equations, right, in z. So mod of z is equal to 1 and mod of z by z bar plus z bar by z equal to 1, right? So we can again observe a very important thing here, that this z by z bar is just the conjugate of this, right? So if we see this z by z bar as some complex number w, then this is w plus w bar, right? So w plus w bar, we already know w plus w bar is 2 times real part of w, right? So we can write this as 2 times real part of z by z bar. Okay, this modulus will be equal to 1. And why this modulus? Because real part can be both negative and positive, right? Modulus of a complex number basically denotes the distance of the complex number, the point which represents the complex number from the origin, right? So we have these 2 points basically, one corresponding to plus and one corresponding to minus. That's why we have this modulus sign here. So this we can write as mod of real part of z by z bar is equal to half. Okay, so let us calculate this real part of z by z bar. So z by z bar, if we calculate the real part, this will be real part of, if we let's say multiply both numerator and denominator by z. Okay, so that this denominator will be z bar, which is mod z whole square, and mod z is given to be equal to 1. Okay, so this denominator will vanish. That means this we can write as real part of z square. Okay, so real part of z square, we already know this is equal to x square minus y square, right? Because z is x plus iota y, right? And uh, z square is x square minus y square plus 2 iota xy, right? So we have real part of z square, this, right? So this modulus is half. That means we have x square minus y square equal to plus minus half. And from this information here, mod of z equal to 1, we have mod of z square will be equal to 1 again, right? So mod of z square is x square plus y square, right? This is equal to 1. So we have two simultaneous equations in x and y. Now we have to solve this, right? So let us solve this. So if we take case 1, okay, case 1, if we take the plus sign here, x square minus y square equal to half, and then x square plus y square equal to 1. Okay, so if we solve this, we get x square equal to 3 by 4, right? And y square will be equal to 1 by 4, right? So now we can say easily that how many complex numbers will be there satisfying these two criterions. There will be total 4 complex number, right? Because let's say x equal to plus root 3 by 2, then y equal to plus half will be a combination, then x equal to minus root 3 by 2, then y equal to plus half will be again another combination, and similarly the other two combinations will be there, right? So we have total 4 complex numbers in this first case. Now let us analyze the case 2 here. Okay, so case 2, if we say, this will be x square minus y square equal to minus half, and this x square plus y square equal to 1. Okay, so we have x square as 1 by 4 and y square as 3 by 4, right? So we again have here 4 distinct complex numbers. So that means 4 complex numbers, right? So altogether we have total 8 complex numbers satisfying these two simultaneous equations. Okay, mod of z equal to 1 and mod of z by z bar plus z bar by z equal to 1. Let us jump to the final problem of this session. Okay, so this is the next problem. Let O be the origin, the point A be this complex number. Okay, z1 equal to root 3 plus 2 root 2 iota. So this iota would be outside this square root. Okay, the point B, which is z2, be such that root 3 times mod of z2 equal to mod of z1. Okay, and argument of z2 is argument of z1 plus pi by 6. Okay, that means let us visualize this complex number. Okay, so z1 is root 3 plus 2 root 2 iota. That means somewhere here. Okay, and this point B be such that root 3 times mod z2 equal to mod of z1. That means we get from here mod of z2 is equal to mod of z1 divided by root 3, right? So then argument of z2 equal to argument of z1 plus pi by 6. That means if we consider these two vectors representing these two complex numbers, okay, like this, let's say this is the z1 and this is the z2. This vector corresponds to this complex number z2 and this vector corresponds to this complex number z1. The angle between them is pi by 6. That means this angle is pi by 6, right? And what is the significance of this plus sign here? The plus sign here indicates that we have to travel from z1 towards z2 in anti-clockwise direction. Okay, so this signifies the anti-clockwise direction. And mod of z2 is mod of z1 divided by root 3. That means this complex number z2 is closer to this origin. Okay, the mod of z2 is less than mod of z1, so this number is closer to this origin. That means if I join this triangle, okay, this is point b, this is point a, and this is point o, and this triangle is abo, then we can find easily all the informations of this triangle. Okay, area of triangle, whether this abo is a scaling triangle or obtuse angle, isosceles triangle or not. Okay, so this information we have to find. Now let us check the area of this triangle. So area will be half times product of any two adjacent sides. So let us take z2 and z1 in this case. Okay, oa and ob. So mod of z2 times mod of z1 times sine of angle between those two sides. That means sine of pi divided by 6. Okay, so 1 by 4 here from this 2, and now mod of z2 we can substitute mod of z1 divided by root 3. That means mod of z1 square divided by root 3. Okay, so from here mod of z1 square, if we calculate, mod of z1 square will be how much? It will be 3 plus 8. Okay, 11. That means this becomes 11 divided by 4 root 3. That means this 1 and 3, none of them are correct. Okay, so we have to check option 2 and option 4. Now in option 4 it is saying abo is an obtuse angle isosceles triangle. So let us check this sides lengths. Okay, so we can say OZ2 or OB is not equal to OA, right? Mod of Z2 is not equal to mod of Z1. So this two sides are not equal. But let us check these two sides. Okay, so let's check OB and AB. So OB side length is mod of Z2. Okay, and this AB side length will be mod of Z2 minus Z1. So mod of z2 minus z1, we can apply the formula of difference of two complex number and their modulus. Okay, so this will be mod of z2 square plus mod of z1 square minus 2 mod z1 mod z2 times cos of angle between these two vectors. Okay, z2 and z1, ob vector and oa vector. That means cos of pi by 6. Okay, so we can say from here, let's check this ab. AB becomes, this becomes under root, then it becomes mod z2 square. So mod z2 square is let us keep this as it is, plus mod of z1 we can substitute from here, it will be root 3 times mod of z2, right? So it will be 3 times mod z2 square minus then 2 times mod z1 z2. So this becomes mod of z2 square times root 3 times 2 times the cos of pi by 6. So cos of pi by 6 we know it is equal to root 3 divided by 2, right? So from here it will be mod of z2 square plus 3 mod z2 square minus this, we get it will be 3 mod z2 square. Okay, so this and this cancels each other. That means we get AB equal to mod of z2. That means AB and OB are equal. Okay, so this means this side and this side are equal. So OBA should be an isosceles triangle. Now whether this is obtuse angle or not, we have to check that. Okay, so this angle we know, this angle is pi by 6, right? So by the property of triangle we can say that if these two sides are equal, AB and OB are equal, that means this angle BOA and angle BAO should also be equal. That means this angle will also be pi by 6. So pi by 6 plus pi by 6 is pi by 3. So this angle here must be pi minus pi by 3, which is 2 pi by 3. That means this is an obtuse angle. That means option 2 is wrong. Okay, this triangle is a isosceles triangle, not a scalene triangle, but it is an obtuse angle isosceles triangle. Okay, so option 4 will be correct option in this case. So this is the next problem. Let z1 minus 8 minus 2 iota, this modulus less than equal to 1, and mod of z2 minus 2 plus 6 iota less than equal to 2, where z1 and z2 belongs to the set of complex numbers. Then the minimum value of mod of z1 minus z2 is 1. Okay, so this is a disk. Okay, closed disk. So the center of this disk is 8 comma 2, right? So we have this two disks here, 8 comma 2 with radius 1, let's say somewhere here. Okay, and this radius is 1 unit. So radius is 1 unit. Okay, and then we have this z2 lying inside this disk of radius 2 units with center at 2 comma minus 6. So 2 comma minus 6 will be somewhere here. Okay, with radius double of this disk. So let's say this is our disk. Okay, this disk is touching the y-axis. So we have this two disks. Z1 is lying on this and Z2 is lying on this, and as well as inside this disks. Okay, so we have this. Then the minimum value of mod of Z1 minus Z2. Okay, so this we have to find. So tell me, when will this minimum distance occur? Right, this is nothing but the distance between Z1 and Z2, right? So when will this occur? This will occur when they are along the line joining the centers of these two disks. Okay, so let us join the centers. So we can say the shortest distance between them will be along this line. Okay, so Z1 will lie here. Okay, Z1 is this point, this is Z1, and this point is our Z2. Okay, so this minimum distance we have to calculate. Now what will be this distance? So if we calculate from here, this center is 2 comma minus 6, right? And this center is 8 comma 2, right? So this distance, let's call this d. So our d, which is the minimum distance, minimum value of mod of z1 minus mod of z2, sorry, mod of z1 minus z2, this distance, this minimum value will be equal to distance between the centers of the disk minus the sum of radius. Okay, sum of radius of this circle, this disk and this disk. So sum of radii. So this distance will be distance between 8 comma 2 and 2 comma minus 6 will be 6 square plus 8 square under root, right, minus the sum of radii, which is 1 plus 2, so 3, right? So we have this 6 square plus 8 square is standard value. We have to remember this is equal to 10 square, right? This is equal to 100, so we can write this as 10. Okay, 10 minus 3, d will be equal to 7. So in this case our correct option will be option number 2. So I hope you all enjoyed this session. If you like this session, do share this session with your friends and fellow aspirants, and do comment in the comment section below what chapter should I cover next in this PYQ discussion series.